You flip a switch and the room fills with light. You plug in your phone and energy begins to flow. You touch a metal doorknob and feel a tiny shock. You think you understand electricity. It powers things. It moves through wires. It is a kind of invisible fluid that runs from one place to another. But that picture is wrong. Not completely wrong. Just wrong in the way a child's drawing of the solar system is wrong. Useful, simplified, comforting, and deeply misleading. You imagine electricity as something inside the wire. Tiny particles traveling down a copper tunnel like water through a pipe. You imagine that when you turn on a switch, electrons rush from the power plant to your lamp at nearly the speed of light. But they don't. In fact, the electrons inside a wire move astonishingly slowly, millimeters per second, slower than a crawling ant. If electricity depended on electrons physically traveling from the power station to your home, the lights would take minutes, even hours, to turn on. Yet they don't. The light appears almost instantly. So something else must be happening. This is where Richard Feynman's clarity becomes unsettling. He insisted that before we say we understand something, we should ask a harder question. What do we actually mean? What is electricity? Not what it does, not what it powers, not how we use it. What is it? You might say it is moving electrons, but electrons exist even when nothing is powered. A copper wire sitting idle is filled with them. So electricity cannot simply be electrons. You might say it is energy, but energy is not a substance. It is a property, a bookkeeping quantity that describes change. Saying electricity is energy is like saying a river is speed. It describes something real, but it is not the thing itself. Here is the destabilizing truth. Electricity is not a thing moving through a wire in the way intuition suggests. It is a coordinated behavior of electric fields and charges interacting through space. The wire is not a tunnel, it is a guide. When you flip a switch, you are not sending particles on a journey across miles of copper. You are rearranging an electric field that already fills the entire circuit. That rearrangement propagates near the speed of light, nudging electrons everywhere, along the wire almost simultaneously. The current is not a stream racing forward. It is a collective response. And if that already feels less solid than the water in a pipe image, good. Because understanding electricity begins with letting go of the comforting metaphor. The deeper question is not how electrons move, it is why the field exists at all. And to answer that, we have to look at something even stranger than flowing charge. We have to look at empty space itself. If electrons drift so slowly, then what actually happens when you flip a switch? Imagine a long pipe completely filled with marbles, touching end to end. If you push one marble in from your side, a marble pops out instantly at the other end. Not because the first marble traveled the entire length, but because the push propagated through the system. Electric circuits behave in a similar way, but more subtly. When a battery is connected, it creates a difference in electric potential. That difference establishes an electric field throughout the entire circuit almost immediately. The field is not inside the electrons. It exists in the space around them. And this is where intuition starts to fail. You think the wire carries electricity, but the wire's real job is to constrain and guide charges. The actual transfer of energy happens largely in the electromagnetic field surrounding the wire. The energy flows through space, not by tiny pellets rolling through metal. This idea sounds abstract until you consider something ordinary, a simple light bulb. The moment the switch closes, the bulb glows. But no electron from the power plant has arrived. Instead, electrons already inside the filament begin to move because the electric field has reorganized across the entire circuit. That reorganization travels at a significant fraction of the speed of light. The electrons barely drift, yet the effect is immediate. So electricity is not about rapid particle migration. It is about a field influencing charges collectively. You might say, fine, it's a field. But what is a field? That word feels like an explanation. yet it often hides our ignorance. A field is a way of assigning a value to every point in space. In the case of electricity, it tells us how a charge would move if placed there. But here is the unsettling part. The field exists even where there are no charges. Empty space is not empty. It is structured. When a battery creates a potential difference, it rearranges that structure. The change in structure is what propagates. The electrons respond locally, nudged by their immediate environment. No single electron needs to know what is happening miles away. It simply reacts to the field at its position. Electricity, then, is less like water flowing and more like tension spreading across a stretched fabric. But unlike fabric, this medium cannot be seen or touched. It is not made of material threads. It is a mathematical description of how space behaves in the presence of charge. The more you examine it, the more electricity stops looking like a substance and starts looking like a pattern of relationships. Charges create fields. Fields influence charges. The system feeds back on itself continuously. And this feedback is constant. Even when no current flows, the potential for interaction is present. The field is ready to respond the moment conditions change. Electricity is not something that suddenly appears when you flip a switch. It is a rearrangement of an ever-present structure. This reframing matters, because once you stop thinking of electricity as moving stuff and start thinking of it as dynamic structure, a deeper question emerges. Where do these fields come from? Why does a charge alter the surrounding space at all? Why should space have the capacity to be influenced? At this point, the explanation can no longer remain at the level of circuit diagrams and light bulbs. The familiar examples have carried us as far as they can. To go further, we have to confront what electricity really is, not operationally, but fundamentally. And that means confronting the nature of charge itself. At this point, we have stripped away the comforting image of electricity as a rushing stream of particles. We have replaced it with something less tangible: fields, potentials, relationships in space. But that only moves the mystery one layer deeper. What is a charge? You might say it is a property of particles like electrons and protons. That is correct, but it does not explain anything. Saying charge is a property is like saying mass is a property. It names the behavior without revealing its origin. Here is the uncomfortable truth. Physics does not explain why charge exists. It describes how charge behaves, and how it behaves is astonishingly precise. An electron carries a specific amount of charge, always the same, not approximately exactly. That charge determines how strongly it interacts with other charges and with electric fields. Place two electrons near each other and they repel. Place an electron and a proton together and they attract. You might think this attraction or repulsion means they are somehow aware of each other across space. But that language misleads. Instead, each charge modifies the electromagnetic field around it. That field extends outward indefinitely, weakening with distance, but never abruptly ending. Another charge placed within that field responds to it locally. Nothing jumps across space. The field is already there. This is the key shift. Electricity is not particles reaching out and grabbing each other. It is particles shaping a field, and other particles responding to the shape they encounter. But even this explanation rests on something deeper. In modern physics, the electromagnetic field is not just a mathematical tool. It is a fundamental entity. In quantum theory, what we call particles are excitations of underlying fields. The electron is not a tiny bead-carrying charge like a marble with a sticker. It is a localized vibration in the electron field. Charge, then, is not an added ingredient. It is built into the structure of the field itself. This is where Feynman's honesty becomes important. He was clear that when we ask why at this level, we reach a boundary. Why does charge exist? Why does the electromagnetic field have the properties it does? Physics does not currently provide a deeper mechanical explanation. It provides equations that describe behavior with extraordinary accuracy. The equations of electromagnetism, formalized by James Clerk Maxwell in the 19th century, reveal something even more surprising Electricity and magnetism are not separate forces. They are two aspects of a single unified field. A changing electric field produces a magnetic field. A changing magnetic field produces an electric field. This self-sustaining interplay allows disturbances to propagate through space as electromagnetic waves. Light itself is one of these waves. That means when you flip a switch and an electric field rearranges in a circuit, you are participating in the same fundamental structure that allows stars to shine and information to travel across galaxies. Electricity is not an industrial convenience. It is an expression of a universal field woven into reality. But here is the part that challenges intuition most deeply. The energy delivered to your light bulb does not primarily flow inside the copper wire. It flows in the electromagnetic field surrounding the wire. The wire guides the configuration of the field, but the energy travels through space. This was made precise using something called the Poynting vector, which describes the direction and magnitude of energy flow in an electromagnetic field. The math shows that energy moves in the space around conductors, not simply within them. You think electricity is inside the wire, but actually the wire shapes the space around it, and the energy travels through that shaped space. The implications are subtle but profound. Electricity is not a substance, not a fluid, not a hidden stream of particles racing invisibly through metal. It is the dynamic behavior of a field that fills all of space, structured by the presence of charge. Even in complete darkness, even in an unplugged room, the electromagnetic field exists. Charges are present in matter. The field permeates everything. What we call using electricity is merely arranging charges so that the field changes in a controlled way. So what is electricity really? It is the organized interaction between charge and the electromagnetic field. It is space responding to matter, and matter responding to space. And if that sounds abstract, consider the alternative. The intuitive model suggests little beads carrying energy, like trucks on a highway. The deeper model says reality itself has a built-in capacity for structured influence. Charges are not sending messages. The field is already there, encoding how they will move. The more precise the explanation becomes, the less mechanical it feels. Electricity is not something that travels through space. It is something that happens because of the way space is structured in the presence of charge. And once you accept that, the question changes again. If the electromagnetic field fills all of space, if charge is an intrinsic property of certain fields, then electricity is not an add-on feature of the universe. It is part of the universe's fabric, which means when you flip a switch, you are not unleashing a hidden fluid. You are reshaping a fundamental aspect of reality itself. So far, electricity has been confined to wires, batteries, and light bulbs. Familiar territory controlled experiments, human-made systems. But the electromagnetic field does not belong to our technology. It belongs to the universe. Long before there were power grids or copper circuits, charged particles were interacting across space, inside stars, in interstellar plasma. In the early moments after the Big Bang, electric and magnetic fields were shaping matter. The same principles that light your room govern the behavior of galaxies. Inside a star, extreme temperatures strip electrons from atoms, creating plasma, a state of matter where charged particles move freely. In this environment, electric and magnetic fields do not just guide currents through wires. They sculpt enormous arcs of energy, loop through stellar atmospheres, and accelerate particles to near light speeds. Solar flares are electromagnetic events. Auroras shimmering across polar skies are electromagnetic events. The radiation that carries information from distant quasars across billions of light years is electromagnetic. Electricity is not a human discovery. It is a cosmic condition, and the deeper you look, the less it resembles a utility, and the more it resembles architecture. Magnetic fields thread through entire galaxies, influencing star formation and cosmic structure. Pulsars emit tightly focused beams of electromagnetic radiation with clock-like precision. Even the cosmic microwave background, the afterglow of the early universe, is electromagnetic radiation stretched by cosmic expansion. This means that what we casually call electricity is simply the small-scale manifestation of a universal field that extends everywhere. You think electricity is something you generate, but actually you are tapping into something already present. Even empty space is not truly empty. Quantum theory tells us that fields exist everywhere, even in a vacuum. What we perceive as particles can emerge as excitations of these fields. The electromagnetic field does not switch on only when needed. It persists, silent and structured. And here the scale shifts again. When you look at a light bulb glowing, you see electrons responding to a local electric field. When you look at a radio antenna transmitting signals, you see oscillating charges generating electromagnetic waves that propagate outward. But when you look at a distant star, you are seeing electromagnetic waves that have traveled across space for millions or billions of years. The same field connects all of these phenomena. There is no dividing line between laboratory electricity and cosmic radiation. They are governed by the same equations, the same field, the same structure of space. This continuity is not poetic, it is mathematical. Maxwell's equations describe both the current in a circuit and the propagation of light through a vacuum. Change the scale, and the behavior persists. Electricity, then, is not local in the way intuition suggests. It is embedded in the universe's structure. Every charged particle influences the electromagnetic field around it, and that field stretches outward without an abrupt boundary. The universe is threaded with invisible lines of influence, and yet, despite its universality, electricity does not require effort to exist. It does not consume fuel simply by being. Charges create fields, because that is what charges are defined to do. The field evolves according to consistent rules, whether or not anyone observes it. There is no switch keeping the electromagnetic field active. There is no generator running in the background of reality. The field is not powered. It is fundamental. This realization reframes the scale of what seemed ordinary. When you charge a device, you are not producing something entirely new. You are rearranging an already existing structure in a specific pattern to do useful work. The wire is local. The battery is local. The device is local. But the field they manipulate is universal. And once you see electricity not as a substance moving through metal, but as a manifestation of a field that fills the cosmos, the final implication begins to surface. Electricity is not a tool humanity invented. It is a feature of existence itself, which means understanding it is not just about understanding circuits. It is about understanding the architecture of reality. By now, electricity should feel less like a substance and more like a condition. Not a stream of particles rushing obediently through copper, but a structured relationship between charge and the electromagnetic field that fills space itself. When you flip a switch, you are not unleashing something hidden. You are reorganizing something fundamental. And this is where the disturbing clarity appears. We often believe that understanding something means reducing it to moving parts. Gears turning, fluids, flowing, tiny objects pushing one another. That mechanical instinct runs deep. It feels satisfying because it replaces mystery with machinery. But electricity resists that reduction. At its most precise level, physics does not describe little pellets of energy darting through space with intention. It describes fields, symmetries, and equations. It describes consistent relationships that hold everywhere in the universe. You ask, what is electricity really? The honest answer is not a vivid image. It is a framework. Electricity is the behavior of the electromagnetic field in the presence of charge. Why does charge exist? Why does the electromagnetic field have exactly the structure it does? Why do Maxwell's equations describe reality so accurately? At this depth, physics becomes quiet. It does not invent comforting stories. It presents the laws and admits the boundary. This was the kind of honesty that defined Richard Feynman's approach. He resisted the temptation to pretend that naming a concept meant explaining it. If a field is how nature behaves, then the explanation stops at the behavior. And that may be the most unsettling insight of all. The world is not built from intuitive little mechanisms hiding beneath the surface. It is built from patterns that are mathematically consistent and experimentally confirmed, even when they defy familiar imagery. Electricity does not travel like water. It does not live inside wires. It does not switch on and off in the way our metaphors suggest. It is a manifestation of a deeper structure, a structure that exists whether or not we harness it. When your lights turn on, you are witnessing the choreography of charges and fields, interacting according to rules written into the fabric of reality. And the final reframing is simple, but profound. Electricity is not something we created. It is something we learned how to rearrange. The universe was already humming with electromagnetic structure long before the first switch